and welcome to this SUSECon 23 session, Move Your Workload with Ease using SLE BCI. I'm Frédéric Rosa, Linux Container Architect, and today I will walk through SLE BCI, how you can migrate your containers to SLE BCI, and we will do a demo to show you that. But first, what do we mean when we talk about SLE BCI? BCI means base container images. And when talking about SLE BCI, we mean two different things. First, a collection of OCI container and associated a package repository which allows you to build your own customized workload. Those images can be redistributed thanks to a permissive EULA as long as you use SUSE SLE BCI images as a base. Please note that you can have FIPS 140-2 compliance if you associate SLE BCI images with a paid SLES subscription. So we have different kinds of images under SLE BCI. We have what we call the general purpose images. First, the main one is called BCI base. Previously, it was called SLE 15 base container image. So in our case, SLE 15 SP4 for the last service pack available right now. BCI base, and then we have some smaller images for specific use case. We have BCI BusyBox, BCI Micro, and BCI Minimal. Those are usually used for multi-stage builds. We will demo that a bit later. And in addition to those four existing images, we have even another one, which is called BCI Init, which is shipped with systemd. So if we look a bit closer with BCI base, you get glibc, the certificates for everything about cryptography, RPM database, so you can check what is shipped in the container, coreutil, bash, the RPM binary, and zipper. So in the BCI base, you can install any packages very easily. In BCI Minimal, we have put almost everything from BCI base but zipper. Why? Because zipper has a huge footprint in terms of disk space, and you might not want to have zipper on your derived image if you install previously all the packages and then you don't need zipper anymore on your built container. Even further, we have created BCI Micro, where neither zipper nor RPM are shipped. There is still the RPM database, so you can check which packages are part of the container. We have the CA certificates, so any tools which are needed to access SSL or SSH connection will still work properly, coreutil and bash. But for the rest, you have a very bare container. Usually, this is used when you want to run statically linked binaries. And we even have something smaller than BCI Micro, BCI BusyBox, where coreutil is replaced by BusyBox itself. It's a very small container for specific use case. We talked about the general purpose container. We also have a completely different language development images portfolio. With that, you have container per languages, or I should say per languages stack. And this way, you don't have to think about, oh, I need to install this language compiler or this language interpreter. You just pick the right BCI image as a base, and on top of that, you just run your existing compilation or install your own application, which will then use the interpreter or the compiler. So in this portfolio of language development images, we have a .NET container, a Java container, a Python, a Ruby, Node.js, Go, Rust, and PHP. As I said earlier, we have those set of OCI containers, but just that is not enough, because usually you need to install additional packages in those containers. For that, we have the SLE, what we call the SLE BCI repository, which is available by default on all the SLE BCI images. It is pre-configured. You don't have to do anything. You can just, if you use, for instance, the BCI base image, call zipper in whatever packages you need, and it will install them. Currently, it contains more than 7,000 packages. Those packages are coming from the SLE repository, so they are enterprise-grade packages with the proper security fix and reviews that you can expect from a SUSE product. If you want or you need packages which are not available on the SLE BCI repository, because there are some specific packages which are usually not useful for containers, but if you still need those, you can easily have those packages available with your SLE subscription. You just provide the SLE credential, or the SCC, SUSE Customer Center credential, to the SLE BCI image when you build it, and then you have access to the entire standards repository setup. So we have general purpose images, we have a development stack images, and we also have application images in SLE BCI. Currently, we have 4 different applications. We have PostgreSQL database, we have 389DS for LDAP server, we have an OCI registry if you want to run your own registry, and we have RNT, the mirroring server from SUSE, which rely on a Helm setup because it's combined several containers at the same time. So we talked a lot about BCI, but maybe we should try to use those SLE BCI and see them in action. Let's switch to another screen. For this demo, I will show 2 different projects from available on GitHub that we migrated from their own base image to BCI. So first, I will use, let me bring that here, a project which is called distribution. So in fact, it's an OCI registry, and it's written in Go. So this OCI registry can allow you to very easily have your own registry locally, and then push things there, pull them, etc., just like you are used to with any kind of OCI registry. Let me bring. Okay, we have that. So this is the Docker file from upstream, so from the distribution upstream. And let's very quickly go through the various part of this Docker file, and then I will show you how we migrated to this to SLE BCI. So this is using or being built with Go 1.17. It's used an additional tool which is called Go Releaser to basically wrap things, attach tags, git tags to a specific to a commit. It's kind of a very purposed make tool. And then what they do is they will grab these releaser packages from Docker Hub. As one layer, a second layer, they will use the Golang language container based on Alpine as a base image. They copy here, they copy the releaser to the base image. On top of that, they install file and git as package from Alpine. And then they're going to build in another layer the static binary. So this is a bit all this part, which is going to do a bit of mounting between layers. So the static binary will be available to be copied in another layer. This is called multi-stage build, which is quite typical when you are building container in what we call the cloud native framework, where usually a single binary contains everything. So here's a kind of build the registry binary, and then they are going to copy the tarball, meaning the source, the zip file, the checksum, everything, and also the binary to a fresh container. On this container, they make sure to have the CA certificate so that the registry is able to do SSL handshake. They copy a default configuration, the binary itself, and a few setup points for the container. So quite easy. So the only problem is that if you want to have the container and the base container to be fully certified with up-to-date maintenance update and all of that, it's not always possible. You are basically relying on each of the provider of those packages and hope for the best that they are updated in time. You might want to base your workload or this workload on SLE BCI, because this way you are being sure that all the binaries which are provided by SUSE are maintained. So let's see how we migrated this container. You can basically ignore those 3 additional lines. They are used when you want to build container on the Open Build service, which is a tool provided by OpenSUSE and SUSE to build any kind of packages container. But here it's not really that interesting. We have added a label because for this container, one of my colleagues, Marco Varlese, did the initial porting. Also, we added a bunch of labels. Again, those labels might not be needed. It's just we want to be compliant with a lot of the specification in the OCI Open Container spec. So we make sure to tag and put a lot of metadata as part of the container. So we added that. Again, this is basically not needed for your own container. To adjust to do something very smooth, very nice for people who look at it. So we have that. What we did, we have added some arguments so that we can switch which base image is used. We are going to use 2 image, BCI micro for the shipping container, let's call it this way, and BCI Go for compiling the binary. So what we do, we derive from the BCI Go container as a base, and on this base we are going to create a layer for the building, and we do the same kind of tricks which were used by Upstream for their own Docker file to basically set up different mount points so that we can easily retrieve the entire binaries once it's compiled, etc. And we just call Go build because Go releaser was not really useful in our case. So we simplified a lot of the container, the Docker file. As you can see, we didn't have to install Git because for all the development container images, we have Git core pre-installed. You don't have to do that. File, not needed either. So you have already usable language development container when you want to do anything about Go. So building is done, then we create another layer or different container from the BCI macro. Again, BCI macro only contains glibc, bash, the CA certificate to be able to do SSL validation, and that's kind of it. There, what do we do? Just like the upstream container, we copy a default configuration, we copy the binary, and the same entry point for the volume, and which binary should be called, which port should be used, and that's it. So very simple. It's nice we have this container, so maybe we should try to build it. So podman build. On purpose, I had it built already before, but I want to show you exactly what it's doing, so I'm not using any cache. It's fetching the Golang container from BCI. It's fetching, so this one was already in my cache. It's mounting all the things I previously mentioned. It's doing the Go build. It's very fast because it's a small program copying things, and that's it. And at the end, we tag it as registry locally. So let's start it. So podman run the registry. So there, it started. And what could we do with a registry? We could try to push something in the registry. So let's see. Let me switch to another. Increase a bit the font. So here, what I'm going to do is push to the local registry a container that I built for the second demo. I'm calling it DOSBox. The only thing that I'm doing a bit, I disable SSL verification because right now the registry I have running does only do HTTP and not HTTPS. So here it's pushing things. And if you look, if we switch to here, we had a lot of, in the logs, we see that we have pushed, we had manifest for DOSBox container, etc., etc., etc. So that's kind of it. We have a registry which we built, which is built on top of SLE BCI, and that's it. Very simple to migrate a cloud native application to SLE BCI. Our first internal customer for SLE BCI were our colleagues from Rancher. Initially, the entire Rancher stack was built with on top of a lot of different containers. Some built against Ubuntu, some built against Alpine, and we worked together, and they were able to migrate the entire Rancher stack on top of SLE BCI. So, first container was this registry container. Let's see a second one. Which is slightly different. Here we are going to try to migrate a container which we could call, you have legacy container. So imagine you have an application which has been running on your SLE system, maybe a very old SLE system, and you want to containerize it, and it might need additional packages to run. No, not just as the first example where we had a static binary compiled, but here you need a lot of application or packages to run this application. So let's see how we can create this container with SLE BCI, and here we will use also the SLE BCI repository. So in my case, I have a container. It's an application which is running under DOS. It's a old game, and I'm basing my my setup on an upstream container from DOSBox, which is a DOS emulator. And I'm also using a second container to visualize this application running in my web browser. So I'm using a VNC emulation or VNC provider on top of a web browser. So what I want is, I'm using the base container images this time. So I have a very small but usable SLE system with everything you need to install packages and run packages. So I have a few arguments, the zip file containing the game I want to run, a few parameters, and here I need some packages which are not available on SLE BCI because those packages are usually not really needed in the container space. So here I need X11 VNC, which is a VNC server for X11 application, no VNC to make this server available over the network. DOSBox, those are packages which are not available in SLE BCI per se, but they are available on other modules from SLE. They are available on PackageUp, on the SLE module desktop application, and on SLE workstation extension. So the way I do that is I add just one line, which is additional modules, and then the name of the modules I need. And then I will provide my SLE subscription credential during the build. Then there are a bit of tweaking on the no VNC JavaScript, because I have to make sure it's running on all the web browser. I'm copying the the launch command and kind of unzipping the zip file and setting up the entire environment. Here again, I'm not trying to build something. We already demoed that earlier. It's more interesting to see how we can build the container with already pre-built binaries. So let me stop my distribution container. So I'm switching to another another directory, podman build. So I'm going to first try to build the container, but without my credentials. So it's trying to build, fetching BCI base latest, then trying to do the zipper call. And as you can see, in the SLE BCI repository, we don't have, as I said, DOSBox, Fluxbox, no VNC, supervisor, and a few other packages, because there are really specific packages which are not useful when you develop container in general. So let's now do the same, but let me give my SCC credentials. So they, depending how you, which OS you are using, if you are running the podman command directly from a /host, you would not even have to provide those credentials, a /host which is registered. It would inherit the credential. Here I'm using OpenSUSE MicroOS Desktop as my on my laptop, so I just need to provide a file which contains the credentials to podman build, and then that's it. So now it's a bit different. It's contacting SCC, it's adding all the repository. As you can see, the base system repository, the desktop application modules, the PackageUp repo, etc., etc. And it's going to download all the packages, hopefully not too much, because we already use the BCI base image, which contain quite a few packages. Once it's done downloading, it will install the packages. Okay, that's it. So 167, yes, packages that are being downloaded, that will be installed, and then we will be able to check how much working this container is. Let's see. So while it's doing that, also one thing to remember about the SLE BCI repository is it's updated constantly, so you don't have to do anything. Maintenance updates, security updates are pushed automatically to the SLE BCI repository, and the various containers, so the language container, the base container images, and all the BCI container are rebuilt also automatically internally. They passed our QA test, and if everything is green, we release them and you get the latest maintenance update in them. That's it. It's already built. I have a DOSBox container created, so let's run it. Where is it? So I'm going to run it on port 8888. Just some collision on my own system, and let's see. Okay, wrong. Let me run it. Running. Let's see. Let's bring up a browser. Reload. We have a VNC server connecting, and we have, should I say the name? Maybe not, but we have a game running in DOSBox in a container built with the SLE BCI repository and the SLE subscription. Quite easy to do. I don't have the sound. Maybe that's an exercise left to you who are watching. We have Street Fighter 2 Turbo. That's it. Thank you for listening to this talk. I hope you enjoyed it, and see you soon at SUSECon or at any other place.